Hello friends, welcome back to our HB Kabadia school. Myself is Kunal Pandya, and as I told you last time, we are going to discuss in very detail about motion. Okay, so we are going to discuss about motion in detail. So last time also I have told you the definition of motion. Yes, this is the definition. When an object changes its position with respect to some other body. Over here we have taken two different type of things. We have taken one of the things to be the object and other thing to be the body. Okay, then the object is said to be in motion with respect to that body. Okay, some people might feel this is very confusing, so for those I have made a small animation. Please concentrate in that. Again, let's see the definition. When an object changes its position with respect to some other body, then the object is said to be in motion with respect to that body. Let's take consider this is suppose an object. This is a tree. A person is watching a tree. Yes, some people know who is this person. Yes, so this is a tree. Okay, and we are considering this tree to be an object for us. This is the object, and this is suppose a body. Okay, this is suppose a body. So normally if we see a tree, the tree doesn't move from one position to another. Yes, it does motion like oscillatory motion, and it moves its leaves and branches and all, but we can not consider this to be a motion in terms of physics. So when a body, okay, changes its position with respect to some other object, or we can say if an object changes its position with respect to the other body, then it is said to be in motion. So in this case the tree will be stationary with respect to the body. Okay, yes, the tree will remain stationary, that is object will remain stationary with respect to that body. Now let us see a broader image of this thing. Actually these two things are on the earth. Okay, yes, tree, this is the tree, this is the object. If we consider this object to be stationary, okay, if this object is stationary, but earth as a whole is moving on its own axis at some angle. Okay, like this, if you imagine earth is rotating like this, so when the earth rotates, along with that this tree also will rotate. So what do you think with respect to this person, tree is moving? No, with respect to this person, tree is not moving. Why? Because when the earth will move along with this object, the body which is there on the surface of earth, it also will move with the same speed with which the tree is moving. So with respect to a person standing on the earth, this tree is stationary. Okay, this tree is stationary with respect to a person standing on the earth. Okay, but what if there is a person outside the earth? Okay, imagine this, suppose a UFO, it is moving like this. Okay, so with respect to a person standing outside the earth, this tree will be in motion. Okay, tree is in motion. Why? Because earth as a whole is in motion. So with respect to a person standing outside the earth, this object is in motion. With respect to a person standing on the earth, it is not in motion, it is stationary. So we can say motion, whether the object is in motion or not, it depends on the relative concept. Okay, it depends on which reference we are taking. Okay, so again, motion is a relative concept. Okay, please remember this thing forever. This is a relative concept. Okay, motion is a relative concept. Without any relative, or we can say without any reference, we cannot define motion. Okay, it is a relative concept, and we cannot define motion without any reference. Okay, motion always needs a reference. So if a tree is stationary or not, okay, tree is stationary or not, it depends on which reference we are taking. Okay, so tree might be stationary with respect to a person on the earth, and it is in motion with respect to a person which is standing outside the earth. Similarly, if you consider any object around you, consider like TV around you, or something else, okay, which is or a wall, okay, a wall of your room. The wall is stationary with respect to you, but when a person is outside the earth, with respect to that, earth as a whole is moving, so therefore along with the earth, your house and that wall also will move. So motion is a relative concept. Okay, so let's proceed further. Let's see the definition again. The motion of definition is The definition of motion is when an object changes its position with respect to some other body. Okay, we can say when object, we have taken the tree as an object. This is our tree as an object. It changes its position with respect to some other body. In this case we have taken the UFO. Okay, so with respect to UFO, object is changing its position, so therefore this object, that is a tree, okay, therefore tree is said to be in motion with respect to body, that is UFO. Okay, similarly if we consider that this person, okay, which is standing on the earth, yes, people know his name is Tony. Okay, this is Tony. With respect to this person, we can say the body is in body is not in motion. Okay, so let's go further. Now we have some basic definitions of average speed, instantaneous speed and all. So let's go through these definitions, and it will be very helpful to calculate numericals as well. So let's see some definition, basic definition. First we have average speed. Okay, so what is speed? We know what is the distance covered. Okay, we know what is distance. We can also say distance is same as the path length. Distance and path length both are equal. Okay, so average speed is written as, it is written as like this, it is written like this. This is called average speed. This symbol indicates average. Okay, this indicates average. Also we can write average like this. This symbol also represents average. Okay, and V here stands for speed. So average speed is written like this, or it is written like this. It is not a vector. Okay, remember this is not a vector. I have just made a dash on above the V. So average speed is defined as, it is given by the formula. You have to take the distance. You have to take the distance on numerator and time in denominator. So the distance covered in unit time is called path length. We can also write it is, distance covered in unit time is called average speed. We can also write it as path length per unit time. Okay, the total length of path in unit time is called average speed. It is given by the formula. Its formula is delta x by delta t. We can write anything instead of delta x. We can also write delta r or delta y, delta z, whatever you like. Okay, but we have to mention that over here, whatever thing we have written, over here I have taken distance, so I will write it is distance, because in some cases when we are talking about average velocity, it may get mixed up. So therefore we have to always mention that delta x is the distance and delta t of course is time. Now let's see its unit. Unit of average speed is, see, the unit of distance is meter and unit of time is second. So meter per second is the unit of average speed in MKS system. Okay, that is meter kilogram second system. Its unit is centimeter per second also. This is the unit in CGS. Okay, it's a dimensional formula. It's a dimensional formula. Dimensional formula is L1 T minus 1. Don't worry about this part. Okay, I will teach you what is the dimensional formula in chapter number 2. Okay, so don't worry for this part right now. Just remember this thing. This is the unit in meter per second. This is the unit in centimeter per second. In some cases also we are taking the commercial unit, that is kilometer per hour. This also is the unit of average speed. Okay, so this was all about average speed. We'll go it in detail in our next lecture. Okay, after 2 lectures we'll be going into the detail of average speed, which informations are obtained with the help of average speed, which informations are not obtained with the help of average speed. We will see that part in our next lecture. So this was average speed. This was the things you should know about average speed before proceeding further. So therefore I have just given this much information. Let's see instantaneous speed. Okay, so there is a difference between average speed and instantaneous speed. Also we'll go into detail with this instantaneous part. Let's have a generalized idea right now. Instantaneous means what? If we are finding out velocity at each and every instant of time, or we can say speed at each and every instant of time, speed at each and every instant of time is called instantaneous speed. This instantaneous speed, unlike like average, okay, in case of average we have written it like this. See, this is the symbol of average. Okay, in instantaneous, the value of a change in position, or we can say the distance, is very small. Here if we are taking delta to indicate the change. Okay, this delta indicates change. I'm writing down it over here. Here the delta indicates change. The change is very small, then we have to write it as v is equal to dx by dt. This is the equation of instantaneous speed. I will tell you how it became dx by dt. I will give the concept about limit, okay, in next upcoming lectures. Before that, I will teach you what is differentiation, because right now the thing which is appearing in front of you, that is a d. Okay, you might not know what is this d. So in upcoming lectures, see, this is the d. This also, here it is a d. It is nothing new, but it is just we can say if delta represents change, then this small d represents very small change. Okay, so if delta represents change, d represents a very small change. It's a unit and dimensional formula are same as that of average speed, that is meter per second, or we can also have centimeter per second. Okay, these two are the units, and its dimensional formula of course is L1 t minus 1. I have told you, don't worry if you are not understanding this part, because I will teach you. So this was a generalized idea about instantaneous speed. In upcoming lectures I will also tell you why we are defining instantaneous speed, how delta becomes d, and what exactly is d. So those things we will study in next lectures. So this was generalized idea. Again, like average speed, we also have to define average velocity. These two things are different, because in last lecture I also told you that displacement and distance are different. Similarly, velocity and speed also are different. So let's see what is average velocity. Average velocity is a ratio of total displacement you can also write just displacement. Okay, no need to write total. So the total displacement in unit time is called average velocity. Average velocity, like average speed, also it is indicated as v. Okay, as it is a vector quantity. What are vector quantities? It is there in chapter number 4. Right now just consider this is the vector quantity. Average velocity is given by the formula dr by dt. This is the this is the formula for average velocity. Okay, this is the most important equation. V is equal to dr by dt. Don't worry about this. Sorry, I have written, you have to write delta, because it is not instantaneous. You have to write delta r. Okay, yes, delta r by delta t. This is the formula of average velocity. Here also average velocity, we have to mention what is delta r. Here delta r is the displacement, and over here this is total time. Now the unit of average velocity and average speed are also same. Velocity and speed are having the same unit and dimensional formulas. Its unit is meter per second, or we can have centimeter per second, also have it in kilometer per hour. It's a dimensional formula is L1 t minus 1. Okay, so this is the average velocity. Okay, Yes, let's see the next thing, that is instantaneous velocity. If we find out the velocity at each and every instant of time, then it's called instantaneous velocity. Okay, this is what velocity at each and every instant of time. This is called the instantaneous velocity. It is indicated as v and given by the formula v is equal to dr by dt. Okay, this is the formula of instantaneous velocity. Okay, its unit also is the same. Its unit is meter per second. Its dimensional formula also is same, it is centimeter per second, and sorry, its dimensional formula is L1t minus 1. Its other units are centimeter per second, or we can also have it in kilometer per hour. Okay, so this was all about instantaneous velocity. Don't worry if you are not able to understand what's d, because for our next lecture will be totally dedicated for calculus. Okay, calculus and integration, that is differentiation and integration, in which you will be having a basic idea of mathematics which is related with physics. So let's see next. So these are the pure NCERT lines. I have taken it from NCERT about average velocity and average speed. When an object changes its position, when an object is in motion, its position changes with time. Of course, when it's motion, its position will change. So average velocity is defined as the change in position or displacement divided by the time intervals delta t in which the displacement occurs. So average v, this is the symbol for average. So average v is equal to x2 minus x1 by t2 minus t1. Here delta x is nothing but the displacement, and delta t is the time. Okay, over here it is not given in the vector form. They have not written in the vector form, and that is because we are just studying motion in a straight line. Okay, so when there is a motion in a straight line, that is a probability that these two are this displacement and path length may be equal. Okay, so therefore it is not mentioned over here. So this was all about average velocity and average speed, which is given in our NCERT, and I promise I will give you these things in very detail in next lecture. So let's see next. The graph of distance versus time, position versus time. Graph for an object moving with positive velocity. Another graph is moving with negative velocity, and third one is for rest. So imagine a particle moving along plus x direction. Okay, imagine a particle moving along plus x direction. Initially this is x and this is suppose t. So initially when time t is equal to 0, its position is suppose at when time is equal to 0, its position at 0. At a time t is equal to 1 second, its position is 5 meter. At time t is equal to 2 seconds, its position is 10. At 3 it's 15, and so on. In that case we will have a graph like this. Okay, this will be the graph when the position versus time have a positive velocity. When it is moving along a negative direction, okay, so in that case we'll have a graph like this. Okay, and the body is at rest, you can say when the time changes but the position remains the same, at that time we'll have a graph like this. Okay, this graph indicates that the time is changing but the position is not changing. Okay, so this was the position time graph for an object. First one is for positive velocity. If the graph is like this is having the positive velocity, is having the negative velocity, and this is for object which is at rest. Okay, so we just studied about the average velocity. Now let's see what is average speed. Average speed is defined as the total path length. I just told you is the total path length divided by the total time taken. Okay, so average speed is given by the formula total path length divided by total time interval. Its unit is meter per second, and also we can write it is centimeter per second. In some cases we can also take kilometer per hour. Okay, in SI system, that is system international, okay, this is, if we have SI system, it is always we have to take meter per second. Okay, let's see next. Yes, with the help of this example, see, we have seen this example in our displacement and path length portion. Now we see the same example, we can apply the same example for average velocity and average speed also. So in this case, consider this is the initial position, this is A, this is the initial position, this is the final position. Consider our object is moving, this person is moving from point A to point B on this path. Okay, it is moving via this path. In that case, his displacement will be, see, what is the initial position? He was initially at point A, his final position is at point B, so therefore the displacement is 5 kilometers. So we will write his displacement is 5 kilometer. Displacement always deals with the final and initial position, it doesn't depend on the path. Now let's see what is the distance traveled or path length in this case. In this case the path length is, this is 10 plus 5 plus 10, that becomes 25. So we can say distance covered, or we can say path length over here is 25 kilometer. Now if time taken for this condition is, if time t is equal to 1 hour, okay, let's take let's keep the thing simple. Let's say time is suppose 1 hour. In this condition, if we find out average speed, okay, we find out average speed, then our answer will be, see, average speed means total path length upon total time. So over here the path length or the distance traveled is 25, so we have to take 25 kilometer in 1 hour, means 25 kilometer per hour. So this will be our average speed. If we find out average velocity, then we get average velocity is the displacement upon time taken. Over here displacement is 5 kilometers, so we'll write it is 5 kilometer per hour. Okay, so this is the average velocity, and the another thing is the average speed. So these two are different things. Okay, don't consider this to be the same thing. Average velocity and average speed are different from each other. Okay, so over here, if in case the object is moving directly from point A to point B in 1 hour, okay, if he takes 1 hour to take to move from point A to point B, then in comment section tell me what will be the average speed and what will be the average velocity. Okay, so let's see the next topic. Yes, this is the same thing which I have just told to find out. If this is the hint for the question, we can say, if the motion of an object is along a straight line, if the object is moving along a straight line in the same direction, then the magnitude of displacement is equal to the magnitude of total path length. Okay, displacement and path length will be equal. Now rest you have to imagine, you have to put these values in the formula of average speed and average velocity, find out the answer and keep it in the comment section. Now comes the next definition. See, these are the definitions. I will not go into very much detail in these things because already I will dedicate some lectures, but it's just a generalized introduction of all these things. Okay, so if you don't understand, then also don't feel as if it's not working for you. It will work after 2 or 3 more lectures. Yes, so we have limitations right now, that's why. So this is let's see average acceleration. Average acceleration is indicated as A, and it is, well, let's see the definition first. It is a change in velocity. It is a change in velocity per unit time. See, whenever you accelerate the vehicle with the help of a knob which is given on your vehicle on the right side. Okay, imagine if you are driving a vehicle, what is there on your right side? You have a knob which is called accelerator, and you just rotate that knob and the vehicle accelerates. It means when it's accelerating, its velocity increases, or also it may decrease. So change in velocity per unit time is called acceleration. So the knob which you are rotating while driving a vehicle on with the help of your right hand, so that thing is accelerating the vehicle. So therefore that specific knob on the right hand side of the vehicle is called accelerator. Okay, therefore because it is accelerating the vehicle. Okay, the formula of acceleration is, it is given by the formula. This is the symbol for average. Yes, this is the symbol for average. A stands for acceleration, and this is called average acceleration. We can also write it like this. This is called the average acceleration. It is given by the formula delta v by delta t. Remember, acceleration is also a vector quantity. We'll write it in next chapter. Delta v is called change in velocity. It's called change in velocity, and delta t is called change in time. So delta t is called change in time, and delta v is called the change in velocity. Okay, so this is the formula of average acceleration. Let's see its unit. Its unit is meter per second square. Also we can write centimeter per second square. Okay, so whenever the velocity changes with respect to time, then it's called acceleration. Okay, then in the upcoming lectures I will tell you which informations are obtained with the help of average acceleration and which are not. This was just a generalized idea about acceleration. Now let's see what is instantaneous acceleration. So whenever, if we are finding out we are finding out the acceleration at each and every instant of time, then it's called instantaneous acceleration. Okay, so acceleration at each and every instant of time is called average acceleration, sorry, instantaneous acceleration. It is given by the formula A is equal to dv by dt. Okay, it is the differentiation of velocity with respect to time. Don't worry, I will teach you differentiation in next lectures. So acceleration is given by the formula A is equal to dv by dt. Here dv is of course the change in velocity, and dt is the time taken for it. Its unit also remains the same. Its unit is centimeter per second square, or we can also write meter per second square. So this is the unit of instantaneous acceleration. Okay, so there is a difference between average acceleration and instantaneous acceleration. In average acceleration, the change in time is very large, therefore the change in velocity also may be very large. In case of instantaneous acceleration, the time taken is very less, so therefore the change in velocity also will be very less. Okay, so this was all for today's lecture. This is the homework for you. Give the difference between speed and velocity. Okay, you will write down this thing and I will check this homework whenever our school reopens. Okay, so give the difference between speed and velocity. Speed and velocities are different. If you just listen my whole lecture once again, then also you can find out some important points of the difference between speed and velocity. Along with that, some also you have to do this homework. Also write down the short notes on, write note on average velocity, speed, acceleration. And also the same thing for instantaneous. I am writing just INST. It just means instantaneous, velocity, speed, and acceleration. So overall you have 7 questions with you. Okay, you have to write about average velocity, also you have to write about average speed, you have to write about average acceleration. Similarly, write a note on instantaneous velocity, instantaneous speed, and instantaneous acceleration. So these are the 6 questions. Along with that, this is the 7th question. So you have to write these 7 questions in your notebook at least 2 times. Okay, you have to write 2 times this homework. Please don't take it lightly. It's your time to study well, because as soon as the school reopens, we'll go with the lectures. We'll not repeat this lecture once again. Okay, so you have to take these lectures very seriously. So finish your homework because it's very important, and remember this thing: no amount of money ever bought a second of time. Okay, so don't waste your time in just playing games and all. Okay, because time is very precious. So that's all for today. Thank you. Thank you very much. So have a nice day.